Today we're looking at binomial probability in section 11.4, and we'll begin to talk about what we call a probability distribution. A probability distribution is a table that includes all the possible values of the random variable x along with the associated probabilities. So let's consider a family with 3 children. Let x represent the number of children in that family that are boys. So as we look, here are the possible outcomes. We could have 3 boys, 2 boys and then a girl, boy, girl, boy, boy and then 2 girls, a girl then 2 boys, girl, boy, girl, 2 girls and a boy, or 3 girls. So as we look, it's possible to have 0, let me get one of my pens here. It's possible to have 0 boys, which comes from that case, and it's also possible to have 1 boy, and as we look we have 1, 2, 3 cases with 1 boy. It's possible to have 2 boys, and we see we have 3 cases with 2 boys. And then finally it's possible to have 3 boys, and we have 1 case of that. So since there are 8 possibilities, we have 1 case where it's possible to have 0 boys, 1 out of 8, 3 out of the 8 we can get 1 boy, 3 out of the 8 gives us 2 boys, and 1 out of the 8 gives us the 3 boys. Note that if we add up the probabilities, we get 8 eighths, which equals 1. So the sum of the probabilities in a probability distribution must equal 1. That's one of our requirements. And so here are all of the requirements that yield a binomial probability distribution. The procedure must be for a fixed number of trials. So in our case we had 3 trials, or 3 children. Okay. Each trial must be independent. Okay. The probability of having a boy on the first child was the same as the probability on the second child, was the same as the probability on the third child. So the outcome on the first child in no way affected the outcome on the other 2 children. So the trials were independent. Each trial must have all outcomes classified in 2 categories. So in this case our success was a boy, our failure was a girl, and the probability of success must remain constant, which it did. It remained at 1/2. So probability of a boy on a single trial remained 1/2. So we met all of those in our probability distribution. Now in calculating probabilities that from when we have a binomial probability distribution, we have a number of ways to do it. There's actually a table we can use. We can use the calculator. If you have a TI-83 or 84 plus, it has a special place where you can calculate it. You can use a computer that is set up with statistical features, or you can use the probability formula. And since we don't use the TI-83, 84 plus as a required element of this class, the probability formula is going to be one of the best ways to do these problems, simply because some of you may not have those calculators that have the nice statistics features on them. So what we're looking at is the probability of x successes. The probability of x successes is found by taking n, and notice n represents the number of trials. So is represented by n factorial over x factorial times n minus x factorial times the probability of success. So in the case of our children, the probability of having a boy was our probability of success. And then our Q, and I started writing P again, our Q is the probability of failure. So in the case above, it would have been the probability of having a girl or not a boy, which also would be 1/2. So we do note that the sum of our two probabilities, probability of success plus the probability of failure, is equal to 1. That means if you know your probability of success is 0.3, the way you can find Q is to take 1 minus 0.3 and you get 0.7. So that's the way you can use this relationship. So in our formula again, N is the number of trials, X is the number of successes, P is the probability of success, Q is the probability of failure. And so basically, if we want the probability of a certain number of successes in a certain number of trials, given that the probability of success is a certain value, such as 0.3, we just plug the numbers into the formula and we can come up with the solution. Now, I believe we have, okay, it looks like our book doesn't have the table so for probability, so it looks like we're pretty much stuck with using the formula that we have here. And one thing I do want to note on this is that it's combinations of n taken x at a time. So you could write the formula as combinations of n taken x at a time times the probability of success raised to x times the probability of failure raised to n minus x. So we can use our combinations on our calculator to calculate this one piece here relatively quickly. Okay, you certainly will want to take a look at the sample problems to see how we use this formula to calculate binomial probabilities.